In this video, we're going to calculate another dosage. We're going to use the nursing formula, dimensional analysis, and a proportion to solve this one problem. Again, if you're watching this video online on YouTube's website, you can click on nursing formula to see it done there, dimensional analysis, or proportion. You can click on those. If you're watching on a mobile device, that feature may not be available, but you can fast forward to find the different methods that we use. In this particular problem, we have a 5-year-old patient who needs to be, they're ordered to receive 240 milligrams of this medication, and this is available, as we are told here, as a liquid. So we need to administer 240 milligrams, and it is supplied, this medication is available, 160 milligrams for every 5 milliliters. In other words, if we give the patient 5 milliliters, they will receive 160 milligrams. So how many milliliters will we administer in order to fulfill our order? If we want to use the nursing formula, we need to first write that down. So we have our desired divided by what we have times the quantity. The desired is what we would like the patient to receive. What is desired is for 240 milligrams. So I will write in 240 because that's the desired order. What we have available, we don't have 240 milligrams available. We have 160 milligrams available. So this have in the quantity, this is where you're going to look at your concentration of the medication that's available. So 160 milligrams is what we have. And that 160 milligrams is contained in what quantity? What size is that 160 contained in? It's contained in 5 milliliters. So we multiply by that size, which is 5. So if we were to multiply these, keep in mind this is very similar to having 5 over 1. We would have 240 times 5, which would be 1200. And we're going to divide that by 160 times 1, which is 160. I'm just writing all this out. So 240 times 5 divided by 160, we get 7.5. Keep in mind, we need to have our unit. We are administering mLs. This is a one-step problem, so we can write mLs. Our solution is we need to supply the patient with 7.5 milliliters of this medication. With dimensional analysis, we are still using the same information. But remember, with dimensional analysis, this is what we use to convert a particular unit that we have, what we are given, and at the very end, we're going to change the unit. That's what dimensional analysis is used for. So what we are changing is the order. With dimensional analysis, you should always start by writing your order with units over 1. We need to administer 240 milligrams, but that's not physically what I'm going to be giving the patient. This patient is not being fed 1 milligram one at a time. What we are supplying are milliliters. So at the very end of our dimensional analysis, I'm starting with milligrams. I better have milliliters at the end. So to do that, remember dimensional analysis using multiplication factors. I want to cancel out milligrams. So that means I need to divide here in my next multiplication factor. I need to have milligrams in the denominator, and I want to go from milligrams to milliliters. Thankfully, this is a one-step problem, so I can do that. If we were started with micrograms, we might have to include more the multiplication factors. But since I know the conversion from milligrams to milliliters, given by the concentration, I can put that in my next factor. 160 milligrams is contained in 5 milliliters. This is the conversion factor between milligrams and milliliters. This is what's going to change for every problem. Notice if I were to multiply here and divide, milligrams would cancel and I would be left with milliliters. So I would have 240 times 5, which we found in that last, using the nursing formula. We get 240 times 5 is 1200, and the unit up top is milliliters. Down below, 1 times 160, which is just 160, and we do not have any units. So when you divide 1200 divided by 160, you get 7.5, and our unit, milliliters. Notice we get the same answer that we did with the nursing formula. Obviously, we should get the same answer. Hopefully, you can also notice that what we are multiplying here, 1240 times 5 divided by 160, was the same multiplication and division steps that we used with the nursing formula. Finally, using a proportion, remember our order needs to be proportional to our concentration. If this is a one-step problem, then this is nice because, again, our order will be in the same proportion as the concentration of the medicine. So I know the concentration is 160 milligrams for every 5 milliliters. That's the concentration. That's the ratio of milligrams to milliliters. The order, whatever I give the patient, is going to be in this same ratio. I know that the milligrams will be up top and milliliters will be down below, because we know if they're in proportion to each other here, the units need to match up. Now, we're looking for how many milliliters. So I don't know how many milliliters, so I'm going to put an X there. Milligrams, well, in the order, the milligrams is 240. So 240 milligrams is going to be in the same ratio of some amount of milliliters that we'll give the patient. That's going to be in proportion to the concentration because there's 160 milligrams in 5 milliliters. This is different than dimensional analysis. With a proportion, we would cross multiply. So we get 240 times 5, which again, we saw from the last couple times here was 1200. 160 times x if we cross multiply. So 160x. We divide both sides by 160. We get x equal to 7.5. If you were lost here, I would recommend that you click on the PACollege link down here. Maybe page through some of the other videos that we have gone over to catch up here. Notice we're not going to leave our answer like this. We do know that our unknown is 7.5. Well, our unknown is being represented by the amount of milliliters. So again, our solution is 7.5 milliliters of this medication needs to be supplied.